Hello, welcome back. So today we are working on a LENNOX package rooftop unit, and it is serving a commercial space, and the customer was saying it's not cooling. The thermostat was turned off. I set it to cool mode, and now we are on the roof and just inspecting the unit from outside. As you can see, condenser fan is running, and if I touch the coil here on the condenser side, it's hot. And so power is on, and this unit doesn't have economizer. So next up, we're gonna open the panel and see what is going on. Okay, so I have opened up the electrical panel. So compressor is working, the discharge line is hot, and here the suction line is cold. And so looks like the unit doesn't have any electrical issue, means the compressor is working. The blower, I don't think the blower contactor is pulled in. So okay, so we're gonna open up this panel and see what is going on. Okay, so the blower motor is not running. Let's turn off and we'll further investigate why it is not working. Okay, so that was strange. I just checked the contactor was okay, and I just retighten all the contactor wiring, and let's give it a try one more time. But the unit condition is like, if you see the filter here, it's completely black, and see the belt has so many cracks, see, and inside see, looks like the belt is gone completely. It could break anytime. So it looks like the unit maintenance haven't been done from a long time. So unit doesn't have any economizer, so of course the bypass plug is there. Okay, so okay, let's turn on. No, the motor is working. That's strange. Looks like a loose wiring or something. Okay, so now we're gonna close these two panels and check what is going on with the refrigeration cycle. Okay, so I have put my thermometer into the supply air area. So it is showing 64. The ambient is, I think, approx 70, 73, 4 something. But definitely unit has some issues with the refrigeration cycle. Could be a leakage somewhere. So definitely running with a low refrigerant. It's R410A. Yeah, see, this is freezing up. So that's another sign of low refrigerant. Okay, so first we're gonna replace our filters and belt, and then of course it is having a leakage somewhere inside, so we're gonna test that. Okay, so this is the new belt, and I try to put the new belt on the pulleys, but it's going very hard, so means we have to adjust the motor. And this is the old belt check the condition of the old bed. It could break anytime, so we have to adjust the motor. So we have to loosen these mounting bolt here, all four, and there is a slot in which the motor can slide forward and backward to adjust the proper tension of the belt. So we have to do it first. Okay, so I have loosened all the four mounting bolt of the motor. Now the motor can slide forward and backward, so we're gonna put our belt and set it to proper tension. Okay, so check it was earlier here, and after putting the proper tension to the belt, so this is like a inch of motor shifting. So the belt size is same. I don't know why it happened, and it is now proper tension here. So over tightening the belt could result driving more amps for motor, so it can damage the motor, of course. So let's give it a try and see how the motor is working. And okay, motor is good now. I have connected my wireless probe to the unit, suction line, liquid line, and temperature probe on suction line and liquid line. So the system is showing 174, 176 on high side, and the system is off now, of course, R410. And so I just wanted to make sure if it is just a low refrigerant, or is there any kind of restriction in the system. So just okay, let's turn on the system. So the low side is going very low, high side is not enough. So definitely we are having a low refrigerant. Let's check the subcooling and superheat data. Okay, subcooling is 0, superheat is way high, suction line temperature is 74, liquid line is 77. So it says 0.3 F, that's the subcooling. Okay, so looks like we have a leak somewhere. So we're gonna next step, we're gonna check the leakage with our filled piece refrigerant leak detector. So we're gonna check our leakage with our filled piece leak detector. So to get the proper access of the coil, I have removed this panel here because the unit doesn't have a economizer. And so we're gonna check here first. Okay, so I have tested with my leak detector the whole evaporator coil on this side. No sign of leakage, not even a sign of oil. I have tested this portion and the inside here, nothing. And the next area is our condenser, microchannel condenser coil, which I have checked in my most possible way. Nothing. And the next thing, these Core Max shredder valve, they are always prone to leak. So far I have found so many leakages through this port. This is a regular shredder valve, this one, and this is our Core Max high flow shredder valve. So they are always leak. So once you disturb the inside core, and they start leak. I don't know what is it's kind of a design issue or something. So for this demonstration, I have put a cap here, and before I blew up the hole inside this area with the air and tested, it was showing no leakages here. and now I put just a cap, hand tight cap. So we'll remove that and test it again, because I remember when I took out these caps, it was it came out like kind of sound. So that was another indication of leakages. So let's take it out. See, I made sure I blew up air and I tested with my leak detector. Earlier there was no sign of leakage. Then I put a cap, and after a few minutes, just a hand tight, and it was showing a leakage. See, very minor leakage. The same thing was happening here. So they have a special tool to replace these kind of serial valve, but I don't have it. And I usually, wherever I find the leakage on this type of Cormax fitting, I put a T fitting with the normal serial valve. So I'm gonna replace the core of the normal serial valve, this one and this one, and put a T cap on this one, because I did not find any leakages anywhere. Indoor evaporator coil, condenser coil, lining, everything was looking okay. Okay, so I have fixed this T fitting on the Cormax serial valve here and here. So I have aligned it proper way, so that if we want to connect a switch or something here, so both way we have access. The same thing goes here. And for the normal serial valve, I have retightened the core, because those were not leaking. I verified few times, those were not leaking. So those were the only two valves having issues. Mainly this one, the section line, it was leaking continuously. So okay, so I have changed the filter, the belt is new, I put back this panel, and we are ready to charge the system. So I have connected my hose to R4108 tank or cylinder, and is directly connected here on this T at the section line, and all my props are ready. And here, this tank, I usually get a comment, you have to put tank upside down, because we always charge R410 with the liquid mode, with the liquid state of the refrigerant. So, and this cylinder, so red knob, we can charge directly without putting the cylinder upside down, because this is directly connected to a tube going all the way to the bottom of this cylinder, and this is for vapor. So we do not use this, and this is how we have cylinder here in Canada. In the US, I know there is only one knob, so they have to put the cylinder upside down to charge it into the liquid state. Okay, so everything is ready, so we're gonna put back our panel, and we'll see the LENNOX instruction how to charge the unit, and we're gonna follow their instructions. Okay, so I have also connected my air probe. This is the return side at this section. Before closing this panel, I just wanted to show you. And the second one in the supply area behind this panel inside. So we're gonna put this panel and see the LENNOX charging instructions. I have opened up my knob here on the cylinder, and I'm gonna purge it here. Okay, so all the air has been taken out, and I'm gonna control the refrigerant flow or amount of the refrigerant through this red knob. So our ambient temperature in the shade is 78. Yes. Okay, so this is the LENNOX charging instructions, and in this case the best option for charging the system is by weight, which is always mentioned on the outside label of the unit. But in this case, we already have a refrigerant inside the system, and we found out the leakage was from the shredder valve, so we fixed that without recovering the refrigerant. If there would be a leakage on the copper lines or somewhere else, which for this one we had to recover the refrigerant from the system, but and charge it by weight. So simply that is the simplest way, but in this method we have to follow these instructions. So these are the this is the table for this is the ambient temperature line here. Our temperature is 78, 77, so we're gonna follow this column here. Suction pressure and discharge pressure, these are the list here. And the second thing, so we have to follow this chart. So at the last point it says, for example, at 95 outdoor ambient, the major suction pressure is 130 psi, the target liquid temperature is 98. This is the last line I'm reading out here. So if the outdoor temperature is 95, suction pressure is 130 psi, so the target approach temperature for the liquid line should be 98. So if we follow this example with this chart, so this is the suction pressure here, this is the liquid temperature, and this is the outdoor temperature. So it says 95 95 outdoor temperature and 130, so these two line matches here, and if we see it's 98 here. So we have to follow this chart here to charge the system. So let's turn on the unit. Okay, so this is the reading after turning on the unit. So first we have to maintain this super subcooling approx to 10, and then we will follow the liquid line temperature with the chart. Okay, so our ambient temperature, this is the stable system, I think running from few minutes, and subcooling is fluctuating. Suction pressure is a little bit high, I know, but superheat is in 16, and subcooling is fluctuating 8, and sometimes it's going hitting 10, 11, 12 and coming down to 7. So but I think this is the best system is doing. So as we see, our liquid line temperature is 80, approx 80, or sometimes it's going to 75, so let's say it's 75, and our ambient temperature is 75, suction pressure is 130 approx. As per this chart here, so this is our suction pressure line, and ambient temperature is approx 75 here, this one. So 130 and 75 is meeting here, and it is approx 78 or 76 something. So it is showing 80, so it is fluctuating. So I think the system is good now with the refrigerant. And let's check superheat, subcooling and the air measurement with our other MeasureQuick app. Okay, so here if we see our suction pressure is going below, sometimes it's going 130, 128, and high pressure side is 273. This is discharge, this is a liquid line temperature, pressure, but that's supposed to be a discharge. It's okay. And superheat is in the green zone. Superheat is in the green zone, and subcooling is in the green zone. Everything is looking okay. Liquid line temperature is 79 point something, and so this is okay. So written line wet bulb is 59, dry bulb 69, supply air wet bulb 48 and dry bulb 51. So everything is in the green zone. Looks like the system is running okay. Compression is also in the green zone. So the system is properly charged as per the LENNOX instruction, and it has been running like from 15-20 minutes. So looking okay. Okay, so the unit has been running properly, cooling properly. We charge the system as per the LENNOX instruction, and the condensate P-trap started, and the water is coming out. So we are good here. See you till next time. Just give your thoughts and new suggestions. All kind of suggestions are welcomed. Okay, see you soon next time.